Monte Carlo conference interval project. So we have, how do we build these intervals? We have our sample mean, x bar, and there's our unbiased estimator. We've got S2 squared. That's also our unbiased estimator. So dividing by n minus 1. We have a variance of our sample mean, sigma squared over n. Now we come to normalizing the distribution of the sample mean. So what we're doing means that it approaches normal. It's very simple. We've seen this stuff before. That brings us to our confidence interval of alpha. And what does this look like? This should look familiar. Talking about Chevy stuff. Except instead of k, we have our z statistic, z alpha over 2, and our standard distribution is the square of this, which gives us our sigma over square root of n. And there we go for a 1 minus alpha. You got any questions about that? You see our mu living in between plus or minus? No? Good.
We did the Monte Carlo simulation. We work with more than one types. It depends about if sigma square unknown or sigma square none. If sigma square none, we will use z distribution and we will use the true sigma. It's related to sigma of population. When sigma is unknown, there is two types. It depends about n, if it's less than or equals 30, or if it's greater than 30. If it's less than or equal 30, we'll use t distribution with the same confidence, with the same significant alpha over 2, but t also depends on the size of the sample size. And we multiply it by s. This is the estimator for sigma because here we don't have sigma. This type we can use z or we can use t. It's the same where n has a large number, especially when n is 100 or more. We did the simulation with more than one type of distributions with different n value, and this is the number of the samples that has the population mean include the confidence interval. We simulated, we trialed 1,000 times. So if you see the numbers, it's approximately 950. That means 95% of our samples include or contain the mean of the population. It's not depend about the size of n, as you see, and not depend about the type of distribution. And the reason is, to explain it, I used the binomial distribution. I did just 100 trial to make it easier to understand, especially when you see the next figure. This is the program that we used, and this is the figure that we had. Here we have 100 sample size. Each line of this related to the confidence interval of each size. For example, the last one, this point related to the sample mean, and the upper is the upper sample bound, and this is the lower sample bound, and this sample included or contain the population mean. The red lines are the sample size which not included the population means, and if you see, we did 100 times and there is 5 samples don't have the population mean. Here there is a comparison between the two types when we use z and when we use t. This the confidence interval that we use it where when sigma square none, we use this as you saw in the last page, this is the confidence interval, this is the sample mean, this is the population mean. This is length related to x to z alpha over 2 times sigma over n. So if this is x bar, it will be here. If this is increased, so this line will be longer. If it's increased, this line will be shorter. When it will be longer or shorter, it will affect about if we will include the population mean inside our confidence interval or not. If you see these questions, it has x bar, z, sigma, n. Z and sigma are constant here, and the things that will move this line up and down is x bar, and n will make this line shorter or longer, because where n